Thank you for joining me in this video. In today's tutorial, we have to teach us remainder theorem. All right. In our last tutorial, we treated that of another way for taking long division, okay, or finding the other factors of a polynomial expression. That is called synthetic division. All right. I will teach us remainder theorem now. The theorem states that if some polynomial f of x is divided by some linear factor x plus or minus a, where a is just some number, then the result of the long division will be some quotient q of x plus some polynomial remainder r of x. Okay. It shows that when we clear this fraction, given this, we will have f of x to be equal to the linear factor plus or minus a times the quotient q of x plus the remainder r of x. So when we expand this expression, add it up to this remainder here, we shall have the multinomial algebraic expression, okay? So now the idea of this theorem is that after the long division or long polynomial division, okay, that we shall have a remainder and a quotient, that is another polynomial of a lesser degree, which we call our quotient, okay, and a remainder. So if there is a remainder, then the factor s plus or minus a is not a factor of what? F of x. It's not a factor of f of x. Okay? So this remainder shows that the linear factor s plus or minus a is never a factor of the multinomial expression f of x. Okay? So let's clean. It also shows that it is not only by long polynomial division or by synthetic division that we can be able to find the remainder of a given multinomial expression. Okay? Also, without the use of long division algorithm, r of x can still be got by evaluating f of x, okay, at x equals to plus or minus a. Okay? Yes, that will give me f of plus or minus a to be equals to r of x. So it shows that actually when f of x is being divided by x minus a in this case, okay, that we shall have a remainder r of a. Okay, so we saw that by direct substitution, okay, we can actually have our remainder without the use of what? Long division method. All right, let's clean. That shows what we mean. So now, suppose we have that of our f of x, okay, all over x minus a, for example, to be equals to the quotient q of x, that is the polynomial of the lesser degree, plus the constant remainder r of x, okay? We clear the fraction to have f of x to be equals to the linear factor x minus a multiplying the q of x, okay, plus what? R of x. Now, if we set x equal to 0, that is x minus a equal to 0, such that x is now equal to a. Now, let us substitute in this equation to have f of a to be equals to a minus a, because x is now equal to a, okay? Multiplied by q of a, then plus R of A. By evaluation, A minus A has cancelled out to turn to 0. We have f of A equals to that 0 multiplying Q of A will turn to 0 plus R of A. 0 plus R of A is still R of A. Therefore, when f of x is being divided by x minus A, it is equal to what? R of A. So do you see here we can actually find the remainder by substitution method without using the log division method or synthetic division method? Alright, for clarity, let us use some examples, okay? Alright, the example I'm to use here is the same example I used when treating the synthetic division method. Okay, suppose we have x cubed minus 7x minus 6 to be divided by x minus 4. We want to know if actually x minus 4 is the factor of what? The numerator. Now, by synthetic division, okay, alright, before that, let me just substitute. Let x minus 4 be set equal to 0 such that x is now equals to 4 when we have solved for x, okay? So now by substitution we have f of 4 to be equals to 4 cubed. In place of x in this numerator, I'm putting what? 4. Okay, 4 to the power 3 minus 7 times 4 minus 6. When we evaluate all this, we shall have 30. So it shows that 30 is the remainder. Okay, f of 4 is equal to what? 30. So our remainder is now 30. Since our remainder is 30, it shows that the divisor here, x minus 4, is not a factor of the numerator. Okay, the multinomial. We can equally find the remainder by synthetic division. Okay, we can equally do that. So let's do it. By synthetic division, since our linear factor is s minus 4, then let us use 4 here. I guess you have known how to evaluate or use synthetic division. So let us write out the constants of the numerator. 1, minus 7, and minus 6. Bringing down 1, we have 1. Multiplying 4 and 1, we have 4. Summing minus... Please, sorry. You know the numerator... The order of the numerator is not complete. I mean the order of the power, okay? So let us fix 0. Okay? Let me clean this. Let me rewrite this again. Okay? Just write up 4, okay? Then write 1, okay? We're supposed to look at what I mean here. S cubed, right? Minus or plus 0s squared minus 7x minus 6, okay? I'm fixing 0s squared here, okay? So that will show that they are supposed to be the quadratic term here, but it is being omitted. So I'll fix 0, okay, as its coefficients here, then minus 7 and minus 6. Hope this is well understood. Bringing down 1, I have this, okay? 4 times 1 is now 4. Summing down, I have 4. 4 times 4 is 16. Summing down, I have 9. 4 times 9 is what? 36. Summing down, I have 30. So do you see our remainder here? 30. Therefore, in standard form, I will now have 1 times the quadratic term. It will now give me x squared plus 4x plus 9. Then plus my remainder, 30 over x minus 4, okay? So 30 is my remainder, whereas the quadratic term here is the quotient, okay? We can still be simplified, okay, by almighty formula, okay? All right, hope you found this helpful, right? Okay, let us still do one more example to stop the video. Let us clean. So it shows that we can actually substitute directly, okay, using the alternate number of the linear expression there, okay, given to us as our divisor to find the remainder, which shows us that the linear factor is no more a factor. Okay, let's have this equation here: 6s cubed minus 5s squared plus 4x minus 17. over s minus 3. So the linear factor is s minus 3. Now, letting s minus 3 equal to 0 and solving for s will give me 3, right? So by synthetic dividing this, I will have, bringing down the constant coefficients, I have 6 minus 5, 4 minus 17. Bringing this down, I have 6. Multiplying by 3, I have 18. Summing minus 5 to 18, I have 13. 3 and 13 gives me 39. Summing 4 and 39, I have 43. 3 times 43, I will have 112. Summing the 2, 129. 129. Summing them together, I will have, that is minus 17 and 129, I will have 112. This is my remainder. In standard form, I now have, since the highest term here has the power to be 3, the new quotient now, the quotient now will now be 6 s squared plus 13 x plus 43 as my quotient, then plus the remainder over the divisor x minus 3. Okay, so it also shows that if I substitute directly, okay, to the numerator using 3, I will also have what? 112. Let's do that so that we quit. Hope you are not finding this thing difficult. I'm doing this thing so fast because I have taught us with the same question how we can synthetically divide a polynomial expression, okay? So by direct substitution, we let x to be equal to what? 3. Then in place of this expression here, we have 6 bracket 3 raised to the power 3 minus 5 times 3 raised to the power 2 plus 4 times 3 minus 17. When we evaluate this thing, we will have 112, which is our what? Remainder. And it says that so far there is remainder, then the linear factor here is, the linear expression here is not a factor of the given expression. Hope you found this helpful. Please do subscribe to my channel. Thank you for watching.